This is a Math 3 lesson summary video for the lesson titled Optimal Designs. This is a practiced understanding task. The purpose of this lesson is for students to use volume formulas to solve problems. This lesson has 4 problems that involve finding volume and solving problems. In this video, we're going to go over the second problem and the lesson. In this problem, we are given a figure that is a piece for a toy. The toy company needs 1 million of these pieces. We know the shape and dimensions of the figure, and we know how much the material to make the pieces costs in price per cubic meter. We need to find how much it will cost to produce 1 million of these pieces. We also need to pay attention to the units. The measurements are in millimeters, but the cost is given in cubic meters. Let's start by finding the volume of one of these toy pieces. The piece is created by subtracting the cylinder volume from the cube's volume. To find the volume of the cube, we would use the formula volume equals length times width times height, or the formula V equals side cubed. Since the side is 7 millimeters, the volume of the cube is 7 cubed, or 343 cubic millimeters. The volume of the cylinder in the cube is found with the formula pi r squared h. By substituting the values into the formula, we find the volume of the cylinder, and then when we subtract the two volumes, we find the volume of the toy piece. The only problem is that the volume is in millimeters cubed, not meters cubed. To change millimeters to meters, we divide by 1,000. Do we do the same thing when converting from cubic millimeters to cubic meters? This time, let's convert the units to meters before we find the volume. We'll use the same formulas and the same process. When we compare the volumes, we can see that since the measurements change by dividing by 1,000, and it takes 3 measurements or dimensions to find the volume, to get the new volume, we need to divide by 1,000 to the 3rd power. Let's look a little closer at why this happens. If the length conversion is 1,000 millimeters equals 1 meter, then the area conversion is 1,000 to the 2nd power, and the volume is 1,000 to the 3rd power. Let's take a quick look at a simpler example of changing measurements. If the measurements of the length are doubled, then the area should multiply by 2 squared, and the volume should be multiplied by 2 cubed. For example, if the original length was 3 units long, the doubled length would be 6 units long. For area, if the original area is 9 square units, if the dimensions are doubled, then the new area would be equal to 36 square units, which is 4 times larger. For volume, if the original volume was 27 cubic units, if the dimensions are doubled, then the new volume would be 2 to the 3rd, or 8 times larger, making the new volume 216 cubic units. Please keep in mind that this pattern of change only happens when all of the dimensions of a figure are multiplied by the same factor. Now that we understand how unit conversions work, let's return to our problem. If we found the volume in cubic millimeters, we can divide by 1,000 to the 3rd power to find the volume in cubic meters. This gives us the volume of one of these toy pieces. But we need to find the volume of 1 million toy pieces so that we can know how much material in total is needed by the toy company. By multiplying the volume of one toy piece by 1 million, we get this volume. Now that we know that we need a total of 0.2935 cubic meters of plastic, we can multiply that by the cost of a cubic meter of plastic to get the cost of the prototypes needed by the company. This cost is $79.25. In this problem, we started by reading the problem carefully and determining what we needed to find. We then identified which geometric figures were involved and their formulas. We found the volumes and carefully converted the units. Then finally, we were able to solve the problem. Alright, that's it for this video. Thank you for watching.